So hello and welcome to another podcast from the Engineering Department at Durham University. As always, my name is Chloe and today we're joined by Amy Kinbrum, who graduated with a PhD from Durham in 2008 and now works in biomedical engineering. Welcome Amy, how are you?
Fine, thank you. Thank you for inviting me.
Oh, that's okay. Okay, so today we're hoping to talk a bit about your time at Durham and then we'll move on to finding out what you've been up to in your career and also your life since graduating. So to start at the beginning, can you tell us a bit about your time at Durham and what made you decide to do a PhD?
I chose Durham University because I was allowed to do a unified engineering degree at Durham. I really couldn't make my mind up on which engineering type I wanted to do. And I really enjoyed the variety of different types of engineering that I managed to do. So we did a bit of civil, we did electronic, which I was terrible at. We did all sorts of really, really cool stuff. But the thing that caught my interest was the biological side of engineering, and so I investigated a bit further with Professor Anthony Unsworth, who I believe still works there, which is fantastic. And he gave me the opportunity to go and work at the Mayo Clinic in Rochester, Minnesota. I only spent a summer there, but it really inspired me to be in an engineering field where I felt I could make a difference to people who really needed some help. While I was there, I got the opportunity to work in a gait lab and to see my first orthopedic surgery and to cut up my first spine, which I suppose is not everyone's cup of tea, but it was really good. But also to work with really, really big machines and understand how bones work with their ligaments and without their ligaments, and kind of understand the technical aspect of the biology. So I came back absolutely buzzing and did my fourth year project on biomechanics. And then there just happened to be an opportunity that was in bioengineering with Tony. But I wasn't quite ready. So I said to him, look, I'm going to go around the world for a year. And if when I come back, it's still there, then I'll take it. Unfortunately, it was. So that's how I ended up doing a PhD. It was a fantastic opportunity to learn more about joints and about myself and how to push myself to learn properly. And the most challenging thing I think I've probably ever done, actually, which was to write an entire thesis. So yeah, I really loved Durham University. It was fantastic. I was very, very focused on my degree, which was good because Durham, for me, needed a bit more life. So I ended up in Newcastle quite a lot.
Yeah, I think we can all relate to that. So can you tell us a bit more about your PhD in detail? What kind of research did you do?
Yes, so I started off looking at sodium azide, which is the chemical that we add to make sure that that the fluid that we use to test joints with doesn't go off. And looking at how long that fluid lasts when we're testing it and whether that's actually equivalent to what happens in the body. So I started off in an engineering capacity doing that, but then obviously very quickly migrated to the biological side. At the time I was doing my PhD, engineering was at the bottom of the hill on the science site, and biology, I don't know whether it's still there, was right at the top of the hill on the science site, up that really, really, really steep pathway. So I spent a lot of time walking up and down that very, very steep pathway. So after I had a look at making sure that the fluid was doing the job that we wanted it to do. Then I started looking at the bearing surface between the two sides of a metal hip joint, and understanding why it wears and how it wears, and what happens to those particles that come off the metal, where they might end up in the body, what might happen to them if they interact with cells. So I did quite a lot of wear testing, and I don't know whether it still exists, but at the time that I did my PhD, the testing machines were underneath the engineering building, kind of just off to the side of the massive civil lab. And they made an awful racket, and people used to walk by and go, oh, I don't know what that is, but that's really annoying. So that was me. I'm sorry. I was in there making that racket every day, every weekend, switching it over. So we test the orthopedic joints to 5 million cycles, and sometimes we test them to 10 million. And my colleague at the time had done a test to 20 million, which takes an entire year. So 5 million cycles takes a quarter of a year. So you can kind of see how many you're going to get in a PhD. And then once you've done the test, then you've got all of these different bottles of serum, the liquid that we've tested it in, with these tiny particles in. So then my job was to separate out those particles and look at them. And we had a machine that identified the particles, not by being able to actually see the particles, but by looking at the Brownian motion of what else you could see, and therefore understand where the particles were moving. So I did quite a lot of that. It looked quite a lot like Space Invaders from an outside perspective. So I spent quite a lot of time, my friends called, just doing Space Invaders, to understand how many particles, what shape they were, and kind of how they existed, whether they existed in clumps all together or whether they existed all separately. And then the final part of my PhD was to look at what effect that would have on cells, which I didn't get terribly far with, but fortunately the rest of my PhD was enough to write up and get my PhD with. So yeah, I really enjoyed the learning process, understanding what was happening in somebody's body when that was happening, and the biological side, and understanding a little bit about the biology of it.
Yeah, that sounds like a really fascinating PhD. So since leaving Durham then, can you give us an idea of the path your career and life has taken?
Absolutely, yeah. So when I was at Durham University doing my PhD, one of my colleagues at the time was working with a new material that was just kind of coming into orthopedics, which was called polyether ether ketone. And she was working with a company, and they happened to want to hire somebody just as I was about to finish my PhD. So I applied for that role and I got it, which was amazing. So I finished my PhD while I was working, finished writing it up while I was working in Blackpool, where the company was based on the old ICI site. And I was then the tribology expert. So they wanted somebody who could talk to all of the different medical device companies about orthopedic joints and how those joints worked with this new polymer. So I spent 3.5 years going on tour around different countries, talking to different people, talking to research institutes about the polymer, how it could be used, how we could manufacture it differently so that we could align carbon fibers in it or not. And then also the flip side of that is talking to research institutes to keep that research going and understand what the polymer could do and where the limitations of it were. And I really enjoyed doing that job, but towards the end of that part of my career, I started to realize that I didn't want to be the person who was advising. I wanted to be the person who was actually developing and designing. So I moved from there into a role in Swindon, where I was working with orthopedic products that were already on the market, but adding new technologies onto them. So, for example, there was already a hip stem on the market, but we were going to add technology onto that hip stem to reduce the amount of infections that was produced. So that was really good fun until my department got made redundant, unfortunately. And so I chose voluntary redundancy at that point and moved into a role in a company in Swindon in a lab, and I built up the lab from 2 machines up to an entire array of machines, and we were ISO accredited and that thing. And it was really good fun working with a new company, a much smaller company, doing ISO standard testing, trying to develop new tests, and understanding the fatigue properties of hip joints particularly, but also knee joints, and just making sure that the products that were on the market were safe and effective for the people who were using them. So I stayed there for 4 years, I think, and then I got a phone call one day from somebody saying, we'd really quite like a lab manager in this lab. And I knew that lab would be much, much bigger and much, much more capable. So I went for the interview, and it was beautiful, shiny, glass walls with all the equipment you could ever want in a lab. And so I fortunately got offered the job and became the lab manager there. And I was there for 7.5 years, developing my career, understanding, building up the team, understanding what kind of testing we could do. And then I took some time out to have a baby. And at that point, I decided that I could not balance having a career in a lab where I had to be there all the time with having a baby. So I took a bit of a change in career and started this new role that I'm in now last November. And what I do now is I develop an app for a hospital to make sure that somebody who is going in, for example, for bariatric surgery, can stay in touch with their surgeon, with their nutritionist, with their sports coach through this app that they have downloaded on their phone.
Wow, that sounds really very varied career path and really interesting roles there. So in those roles, what have been some of your favourite projects to work on?
Oh gosh, I very much enjoyed working with a German team on putting a new coating on a hip stem, which so it was sprayed on like with a printer inkjet machine, and it was to reduce the amount of infection that you get at a surgical site. So I learned all about the chemistry of antibiotics and how you combine them and how they eke out slowly over time, and how they can stay on a product, how long they can stay on a product, and that sort of thing. That was really interesting to me, and I really enjoyed that. I also very much enjoyed my time at the Mayo Clinic, learning about the dynamics of a wrist and how a wrist will function if you cut some of the ligaments in the wrist, and how people cope with severed ligaments and tendons in their hand. So yeah, it's all been absolutely fantastic, but those two particularly stand out.
Oh, that's great. And what skills and experience would you say have been most valuable in your career so far?
I think this skill, which I'm still learning, to not worry too much about what's happening right now, not panic, just get on with it and do it to the best of your ability. Don't lose sleep over it. It's not the biggest thing in the world if whatever it is that you're doing doesn't happen. Has really helped my resilience and make sure that I don't fuss too much about work. It is only work. It will be there tomorrow if I don't finish what I'm doing today. So that's been really important, but also communication has been absolutely key. So as long as you tell people what you're doing and when you think you might finish it, and if you're not going to finish it on time, you let them know. Actually, everyone's pretty good about you not doing what you think you might be capable of doing. So those two skills are their softer skills, but they are absolutely important for my career so far.
Yeah, that's great. And I think trying not to worry too much is very relevant at the moment because we've all got exams coming up. So good to bear in mind. So looking to the future then, is there anything in particular in your career or in your life in general that you'd like to achieve or that you're working towards?
So the medical industry is moving towards a digital platform, as in we can now take so much data, but we don't really have the capability to process it properly and to understand what that data really means. I'm really looking forward to the point at which I return to R&D, because technically what I'm doing now is marketing, and get to play with the sort of data that I can collect at the moment and understand where it can take us in terms of development and what kind of information we can use and move forward with. I think that's, at the moment, that's the next big thing for me, to be able to manipulate that data and understand what it really means for us.
Okay, and finally then, to finish off, what's your favourite memory from your time at Durham?
It's going to be, this is an odd memory, but it's really good. So every morning I used to have to walk from the bus station, or just behind the bus station where my house was, down the river all the way to the science site, and then up to the science site and by the pub, obviously. And I used to absolutely love those walks in the morning along the river, and it was a little bit frozen and icy, and I was running because I was always late, and I'd get into my lecture and my face would be so cold that I could hardly feel it, and it was really nice to have that exercise in the morning and to have the river to walk down, and it was really lovely.
Yeah, no, that's very true. Very true. It's really lovely being around Durham and all the river and the city centre. So yeah, that's great. Completely agree with that. So thank you so much for joining us, Amy. It's been really great to hear from you. I've certainly learnt a lot because I don't really know anything about biomedical engineering. So it's been really fascinating to find out about. And thank you to everyone who's been listening. We hope you've enjoyed this podcast. As always, be sure to keep an eye on our social media pages for future episodes and for news about our department.